Lesson 7.7, pie charts, page number 547. Actually, what a pie chart is a pictorial way of writing a fraction. And if you remember from times past when we were talking about fractions, I would usually relate them to a pie. And if I had a pie and I took that much out of it, that looks close to a quarter of the pie. So if this were maybe made or cut into 8 pieces, I just took 2 out of the 8 pieces, or 25% of the pie. So if this were 8 pieces, I would take these 2, and that would be 2 out of the 8, or 25%. So that's, for the most part, what a pie chart is. But as far as reading one and kind of getting all the information you can get out of it, takes a little bit of practice. If you look bottom of page 547, right-hand side, we've got a pie chart with college students in it, it looks like. And what they're doing is they're saying that we have seniors, there's 9, freshmen, we have 11, sophomores, we have 10, and juniors, we have 15. So if you notice the way the pie chart is, the size of each part has to represent a little bit as far as the number in the chart. So like 15 is the biggest number, so the chart's going to have the biggest amount of space it takes up, whereas 9 is the smallest, so it's going to have the smallest amount of space taken up. But that being the case, the class rank of the members of a drama club. Okay, I don't really care what the class rank is they're necessarily talking about, but they're asking in A, find the total number of members. Well, this is the drama club, so the total number of members would be what makes this entire pie. So in this case, it would be 45 if we add up 15, 10, 11, and 9. B asks the ratio of freshmen to the total number. So, freshmen, total number, there's our ratio. The bottom number is the total, the top number is the portion of the total. C, ratio of find the ratio of seniors to juniors. Seniors, there's 9, juniors, there are 15. And there's the ratio of seniors to juniors. Remember to always reduce, makes life easier, and that's what we're doing there in example 1. If you jump to example 2, they're showing the results from a survey on how often people check their email. Look there on the little side there, they give you kind of a 3-dimensional looking, I'm not even going to try 3-dimensional, I'm just going to go ahead and make it looking down, and we've got how often people check their email. Okay, so 76% check it daily, and 1% less than once per week, and that's 1%. 23% check theirs weekly. Okay, it might be better to look at their graph. It's probably easier to interpret than mine. How many people in the survey check their email daily? Well, let's see. Does it tell us anything about number? Oh, there's 500 people. Okay. So how many people check it daily? Well, it would be 76% of the 500. 500 total, 76% of them check it daily. So 0.76 times 500 would give me how many check it daily. B says, how many people check it once a week or less? Well, once a week is 23%. Less is 1%. So we're going to add those two together to find out the total number of people that check it once a week or less. So that total would be 24%. Do that times 500 or 0.24 times 500 would give me the total number of people, and in this case 120 check it once a week or weekly or less. Alright, constructing pie charts, which would be part B. Constructing pie charts is learning how to make these handy dandy circles here. So every one is a circle, so that's the easy part. So example 3 says construct a pie chart, and we're dealing with a memory stick there that shows the free space used for a 256 flash. So 256 megabyte is our total. We have used 77 megabyte. Alright, so what we're doing is we're making a pie chart there. So what you're going to do is figure out what percent 77 is. So 77 over 256 would give you your percentage. 77 out of 256 is used. So that's 0.30, which is around 30%. So what you're going to do is come up with an idea of where about 30% is. Well, a quarter, that's about 30%, which means this is 70%. The way you label this is you'd say this is the 77 megabytes used, and this would be the difference between these two. That number would go there for the amount of free space. So that's all you're doing, is you're taking the amount used over the total amount you got, get a percent, and you're just kind of guessing there as far as what it's going to look like. Now if you want to be a little bit more exact with it, you can use a protractor, which an example of one is on page 549. And what they're doing there is they're changing your percent to degrees, because every circle has a degree of 360 degrees all the way around. So what I like to do is start in the center and draw a line to the edge, usually horizontal, usually from left to right. That's just me. And we had our 30%. 30% of it was used. Okay, so 30% of the total degrees in a circle is 108 degrees. So that means I take my protractor and I measure 108 degrees, and that ends up being my 30%. That's more exact. And as far as explaining how to use a protractor, they've got just a real brief directions there, because not only do I not have a protractor handy, but you wouldn't be able to see it on the video anyway as far as how it works. But look there at where they got the 108. They started at the right at 0 degrees and they went up and curved to the left. And they used the bottom set of numbers. The top set of numbers is if you're starting on the right and going up. So notice the bottom set starts 10, 20, 30, 40, and the right starts 10, 20, 30, 40. So that's the way to make it a lot more accurate. So whatever percentage you get, just multiply that times 360, and that will give you your degrees. Okay, so that is lecture 7.7.